Welcome, everybody, to Today in Space. I am your space science podcast host from the East Coast, Alex Giafanos, and we are here, episode 283. And this week, we're going to review some really cool news that's not Artemis and not NASA going to the moon, or the eternal struggle of the industry accepting both SpaceX and NASA working in the same area. Even though it's already happening, we're not going to talk about that this week. We are taking a break from that. Honestly, I got back from Florida. I sat next to the sickest man I've ever sat next to on a flight back. It was a fast flight, about 2 hours and 40 minutes or something like that, but ended up catching COVID when I got back. Took me about a week to get over it. Was exhausted. And then one day I wasn't, and I tested negative. And so here I am. I have recovered, and good. It was a good time to reflect on just the trip to Florida, how great that was. But we have so many episodes from last month that are around the Artemis mission and Artemis 1 and what happened when we were down there, when two scrubs happened, and we saw SpaceX launch about 3 times over that same span. So there's a lot to catch up on there. I still have to do my quick review of, where to go see this launch, because right now they're slated to try it again, Artemis 1, September 27th. And they're going to try the cryogenic test to load the fuel to make sure that the leak fix that they did on the quick disconnect valve, if they can fix that with the liquid hydrogen on the 21st, then on the 27th, potentially, of September, there's another attempt. So if you're going to go to that launch, if you're going to try and catch this second wind potential of Artemis 1 launching, I'm going to share what I found out while I was down there, because I think it's good info. If you're going to go to a rocket launch in Florida, where should you go? What are the places to look at? And what should you expect? And one thing I still have to do is put together my short video on what it was like to rent a Tesla Model Y for the week, try out my first electric vehicle, a great one at that, and how I used it to camp out for the rocket launch to get some of the best spots. Not that you have to go that hardcore, but it's going to be a cool video, and it was just fun. I had a blast in the Model Y, way out of my price range, but hey, that's okay. It was a lot of fun. It was cool. So what we're going to do on this episode is I've got some updates from the AG3D Printing Lab, so we'll start there. I'll tell you what's new, what's coming out of there, and some new resin that we picked up, and I'll talk about how that's been, that printing experience. And then we're going to take a trip over to Mars. We've got some cool stories coming out of Mars on the human aspect of it, right? Of if we're going to go to the moon with NASA's Artemis, then what are we going to do when we eventually go to Mars? And how is this all building towards a future where humans can go live out on other planets? And on the moon, we're going to talk about that, and then we'll take a trip and talk about the DART mission that's about to do its test, its, as they call it, kinetic impact, to see if we're better than the dinosaurs and can prevent an asteroid that killed them and may be able to save us in an Armageddon-style spacecraft test. That's what we're going to talk about on this week's episode. Thank you for joining us. If you want to help support the podcast, our sponsor Manscaped, 20% off anything in the store, whether it's the complete performance package, whether you want the Lawnmower 4.0, the Weed Whacker, whatever it is for your male grooming needs that you need from Manscaped, you can check it out at manscaped.com, 20% off and free worldwide shipping when you use the code SPACE. Look, manscaping, I do it because it makes me feel good. Whatever your reason is, whether it's taking care of yourself, whether it's trying to impress somebody else, whatever it might be, Manscaped has the tools for your family jewels and for your wellness in general, right? They help make it simple, and they've got all the tools that you need, high-quality tools. Again, we found out on our trip from Florida that the Lawnmower 4.0 charges wirelessly, which is great. I was able to find a charger that did work, so I wasn't shit out of luck on that one. But manscaping, doing that on the road, making sure it's a bit of a confidence for me. I feel better, makes me feel good about myself. I'm also a Greek man, so look, there's a lot of hair to deal with. But the tools are simple, and the cleanup's great with the newspaper that they have. Just clean it all up, and again, I've got thick Greek hair, so it gets everywhere. I'm not trying to gross you out. It's just the reality, and the manscaping tools can keep up with that. So you know they're high quality. You know they're there for performance, and the performance package is there for a huge bundle that you can get 20% off with the code word SPACE and free worldwide shipping. So check that out if you want to help support the podcast. As always, make sure to subscribe to the podcast. It's the best way to get the word out there. Share with friends and family. Get the word out there. If there's anyone that likes space and just wants to learn something new, keep up to date on all the crazy stuff that's happening in space. And also dive into stuff like sci-fi and other cool stuff like we'll be talking about here in the future. Technology and all these cool stuff that's happening in the future. Show them the podcast. Spread love, spread science. We love you for doing that. Thank you, everyone who does. You can go follow us on social media if you want more of the podcast, more of the space, more all things space and 3D printing and technology. You've got us over at Today in Space Pod on Instagram and Twitter. You've got us at Today in Space on TikTok. And, of course, you've got our 3D printing lab, AG3D Printing, where we bring our ideas into reality. And we're going to talk about our update here in the lab. But if you're looking for a project, a short-term project, you've got a model that you want to print. Maybe the Maker Lab's all full. Maybe it's the school year and you've got a project and you want to go the extra mile or whatever it might be. Maybe it's just something around the house, or you've got an idea. You want to start a business. You think it's real and you want to get one in front of you in your hands so that you can be like, hey, I think this is possible. Let's invest in this. An early prototype. We can do all of that here at AG3D Printing. And we do that here with our 3D printing business. One of the things we're going to talk about in a second, one of our updates, this was our first James Webb Space Telescope spacecraft model, right? This is the first one we ever did. And we've got an updated version and what I've learned since the first time. And that's the beauty of 3D printing and iterative design. If you're a tinkerer, if you're a maker, or if you just want to get as many reps in before you really go all in on a product, on an idea, figure out the things that you didn't know, right? All of those little things, we're able to help bring an idea into reality with that. So we have our FDM printers, which is just like this one here. This is our James Webb Space Telescope coaster that's 3D printed. This is plastic filament coming out of a nozzle that builds from the first layer up, uses gravity to deposit filament, and then there is the resin printer like the James Webb Space Telescope that goes against gravity and dips a UV light cured, a build plate into a vat of resin, and that resin is cured with a LCD screen that's got UV light that comes through when you put the layer by layer shape, and it pulls that out of a vat. And so that's really cool for really high detail models, especially like this James Webb Space Telescope model. It's so intricate, and there's so much more that you can do quality wise. It's been a lot of fun to learn. And recently we wanted to try, the resins we've been trying a lot of them are like model resins, right? They're resins for like mini characters, whether you got like a D&D set or something like that. Really high quality conceptual prototypes, and a lot of the time those resins are kind of brittle, right? Like the classic thing about resin prints is that it may be beautiful, but if you knocked it off a table, it's going to break into pieces. But that's not true of all resins, and one of the things we wanted to try, because we also have gotten into a lot more of like the engineering and like real life use parts, we wanted a resin that was a little bit stronger. So we tried out this eSun photopolymer resin. It's their hard, tough resin. I'm taking this one out because we haven't touched it yet. The one thing about the resin printing, as amazing as it is an extremely, extremely messy process. And I would not recommend this type of 3D printing if you have kids. I would recommend more the FDM, FFF filament 3D printing, because that one, at least you can kind of teach the kids, it's hot, you shouldn't you shouldn't touch that. You're also going to have an enclosure because some of the fumes. So like at least that's a little bit more clear. The resin, I'll be honest, if I didn't know as much as I knew about the resin and how bad it could be for you, I have gloves, I have face masks and shields that I wear, and depending on the resin, as you get to the more impressive resins like the epoxy resins, in this case, this one has a distinct odor, and that's kind of the real downside to a lot of these resins is you've got these things that you're curing with UV, and at the end, after you've washed them and you've hardened all the resin, it's fine. But everything leading up to that is you got to be careful not to expose yourself to this resin too much. I know I work in 3D printing during the day too, and all types of different materials, from resins to composites to metals, a lot of different stuff. The resin stuff is kind of its own beast. It's its own thing, and I know some people who used to work in resin and can't be around the stuff anymore because they were just around it for so much that developed like an allergy to it. So not something to be messed with. But we've got some video from our lab for. We may now have 3 resin printers in the lab, which brings the total of printers in the lab to 8, I believe, across the different technologies that we have, which is just crazy. I mean, this started as something on the podcast that we were talking about. I was just an aerospace engineer trying to graduate and get my degree and move on with my life. And I had a little disposable income, and I figured, hey, I'm going to buy this 3D printer, and it all went from there. I bought a kit, I built it up from scratch, and that taught me so much. And now this 3D printing adventure is everything in my life. It's completely engulfed it to the point where it helps fund this podcast so that we can put this out there. It helps bring our own ideas into reality, right? This James Webb Space Telescope is literally possible because I've picked up designing. I've been designing since I was in engineering school, and that has just carried over to the 3D printer, which is just the tool to make those things real. And that's one of the amazing things. So this hard, tough resin for our new Saturn S ELEGOO printer, which is a larger format printer. So now I can print even bigger things. And so we're printing the largest version of our James Webb Space Telescope, and this is V3. So this is the third version of our model. This was the first one. You could see the sun shield flaps were really, really flappy. They really, I didn't really have any reinforcement like geometries in there, so it kind of just did what it wanted to. Still worked out pretty well. And this was the first time I was able to paint a resin part, so I got to experience that. And then we went to V2, where you could see a lot more of the reinforcement geometries that are in there. And this is the next level, making it even more precise, making it so that even more of the model is higher quality. And then I decided, with some changes, what I didn't like was the original design of the 18 gold panels, and I really didn't like how that assembled. I had another piece that was going to go inside this, but the fit of that was it was going to take too long to figure it out, so I figured, well, let's just paint the entire back of where the primary mirrors are, and then we'll just put that piece over. But I really wanted something that was a lot more panel and less of like the defining lines between all the hexagons. So for V3, we used that third version of the design where it's going to make assembly a lot easier for me because we want to put this up on our Etsy store. This is going to become a product very, very soon, and we're in the final stages of going through that. And so this is the biggest thing I've ever printed on the resin printer, on our largest resin printer. And this hard, tough resin is really kind of like a hard rubber. It's really interesting. And so I printed it. I have basically 3 parts. We have the secondary mirror and these 3 poles. We have, and that there's the ring around all 18 panels, which are now one piece that are going to get installed. So we'll paint each of these and then assemble it. And the cool thing about the resin printing, which, again, thanks to some help from some great friends like Andrew Sink, who we're going to have here on the podcast soon. You can follow him online, another 3D printing guru that's out there. And with resin printing, you don't even have to think about glue necessarily, because what you can basically do is take some of the wet resin, coat it between the two parts that you want to bond, and then just put UV light, and that will actually cure again, and it'll be the same bond as the rest of the part. So that's as good as it gets, really. So assembly on this final version should be a lot better, and I'm really looking forward to sharing that with you guys. But the resin is really interesting. You know, I haven't had to change a lot of the settings since the beginning, which is marvelous and wonderful, and I'm sure there's a lot more that I can learn from there. But this resin definitely has a smell, and I'm glad that I have some kind of a setup to pull out any kind of fumes or any extra vapors that come off for this type of thing. But yeah, that's what's new in the 3D Printing Lab, our V3 JWST, and we're getting into better resins and really expanding the possibility of what's out there. And I'm looking forward to kind of focusing on some projects a little bit more so that we can really get into the details of design and moving with a project with 3D printing, and what are we learning as we build along the way. I know we do a lot of that here, but I would love to do things a little bit more focused. So that's what I'm working on. So follow us at AG3D Printing. You can check our website out at ag3d-printing.com. If you want to get a free quote on your next project or whatever it might be, check that out there. And our Etsy shop if you want to help support the podcast and our lab. To help us go to things like another future Artemis launch, or to go see more rockets, because I need more rockets in my life, that's for sure. Check out ag3dprinting.etsy.com for more. So, if we're talking about 3D printing, let's move on over to the red planet, to Mars. Let's talk about, we have two major things to discuss here. The first is a 3D printing Martian regolith story that's from WSU Insider. This is September 6th, 2022. This is by Sarah Zasky of WSU News and Media Relations. The title of the article is Martian Rock Metal Composite Shows Potential of 3D Printing on Mars. And if we go into the article here, I'll read a little bit so we can get an idea of the story. A little Martian dust appears to go a long way. A small amount of simulated crushed Martian rock mixed with a titanium alloy made a stronger, high-performance material in a 3D printing process that one day could be used on Mars to make tools or rocket parts. It says here the parts were made by Washington State University researchers with as little as 5% and up to 100% Martian regolith, a black powdery substance meant to mimic the rocky, inorganic material found on the surface of the red planet. And while the parts with the 5% Martian regolith were strong, the 100% regolith parts proved brittle and cracked easily. And still, even high Martian content materials could be useful in making coatings to protect equipment from rust or radiation damage, said the main professor Amit Bandyopadhyay, corresponding author on the study published in the International Journal of Applied Ceramic Technology. If you guys really want to nerd out and dive into that, this research article is here. It's called Martian Regolith, Ti6A-L4V. That's the elemental composition of the titanium, and that composites via additive manufacturing. It goes into a lot of the real detail of how they're doing this. Essentially, they have the titanium substrate. They're bringing the powder over the titanium plate, and then they're using a laser to help fuse the titanium and the Martian regolith together to make parts. And it's actually kind of cool how far they've gone, and they go into the really, really in-depth stuff. If you want to get into 3D printing and all the material science that goes behind that, please feel free to nerd out. But really, I think one of the big things that I would love to do some research on. I know there's an episode I have promised you guys that will come out. I'm just really diving into, what it is I would really love to do. I have two areas. One, to be either an analog astronaut, to do a simulated, let's say, Martian mission, just like the Mars Society does, where they have analog astronauts. And there's a lot of these analog astronauts out there. And then there's obviously the potential as we have more missions. We had Inspiration 4, the first all-civilian mission into space. We have all of the Blue Origin missions that are going on. And then, of course, things like 0G and those flights where you can bring up an experiment. There's so much that's going on. And so the potential of any of us to be an astronaut is higher and higher. And if I'm thinking about it, especially after the Inspiration 4 mission, it made me think about what would I do? What kind of scientific mission would I have if I was going to be an astronaut? What would I do? What would I help advance by going up there? And I think 3D printing, like the regolith, the actual soil, and using the resources that are on the planet to 3D print structures, to 3D print whatever we might need out there is a really, really awesome thing to move forward. I would also love to do something with spine research and degenerative diseases like scoliosis and what 0G and those kind of effects long-term in space. I would love to somehow contribute to that if I had that opportunity. But there's a lot. There's a lot. And obviously something about communication and a podcast style in space and being able to apply that as a mode of communication and science education, I think that would be really cool. So there's a lot that I'm thinking about. That's kind of the mini episode right there of the things that I'd like to do. And so like research like this where they're taking, I think it's actually really good that we don't need a lot of Martian regolith to get a lot of the effects that we need. And the idea of that coating is really interesting too, where if you made a structure out of whatever you needed to, right? If you don't need a lot of the Martian regolith to get benefits, maybe you use plastic, regular plastic, or something really, really light, and then you coat it with this titanium ceramic. Then you get all the benefits, and that could be something that you could apply as you get there, right? The structure could be built. There's so much that can be done. I mean, we have our friends at Stoffel Aerospace that are doing that with their ceramic coating of regular plastic 3D printed parts, and they're able to do some amazing stuff. You've got Brian Stoffel's, biking across America and showing off that technology to everybody, and that kind of stuff is happening here on Earth, and it's something that could really benefit the world if we're able to figure it out to achieve something extremely difficult like making humans survive on another planet. We can then learn from that and apply that here. Another great example, while we're still here in Mars, is the MOXIE mission. Now, the MOXIE instrument, if we go to this article from IEEE Spectrum, from Payal Dahar, it's MOXIE shows how to make oxygen on Mars. It's got MOXIE. Results from a test unit aboard the Perseverance rover, the newest rover on Mars, that has scientists optimistic for future crewed missions. So I'll read a little bit of this article here so we can get an idea. But essentially, this device, MOXIE, the Mars Oxygen In Situ Resource, ISRU, utilization experiment, it's an 18-kilogram unit housed within the Perseverance rover on Mars, and it's converting the carbon dioxide in the atmosphere. Yes, one of the major things that we talk about with climate change and one of the major issues we have here on Earth, CO2, it's turning CO2 on Mars into oxygen. That's not only just breaking apart the CO2 molecule, but that oxygen is so high quality that you're actually able to use it for breathing and for fuel storage, so that when we send missions like Starship in the future, they'll be able to have the oxidizer, the liquid oxygen fuel, made from the atmosphere on site and using the things that are there to help us travel. Instead of having to send everything with us, we can make it while we're there. So this MOXIE experiment has really started to show that it's possible. I remember when it first went on the Perseverance Rover, I was amazed it wasn't a bigger story, because this device is literally doing what we would need to do here on Earth to help reduce the CO2 emissions, right? I think one of the major pitfalls of us being human beings on a planet where the CO2 exposure is in so many different things, and to tell a bunch of human beings to stop using the thing that they're using when the immediate danger from a day-to-day perspective in that time frame is minuscule, how are you going to change that incentive when there's so much money and power involved? One of the ways that you could do that is investing in technologies like this that are actually going to be able to convert the CO2 to breathable oxygen and air, just like plants do, right, with photosynthesis. So I don't know why this isn't a bigger story, and why this isn't even like discussed more than it is, but it's doing a fantastic job. So this was something designed in preparation for crewed Mars missions, and they decided to put that on the Perseverance rover. And astronauts will require a total mass of about 50 tons of rocket propellant for the ascent vehicle that will lift them off the planet's surface after they've gotten there, because you want a return trip if you can get one. And it will also include 31 tons of oxygen in that rocket propellant that they're going to need. And obviously the less popular option is for crewed missions to carry the required oxygen themselves, because that's dangerous. It also takes more vehicle capabilities. So, before SpaceX launching as often as they are, bringing stuff into orbit, the idea of having a mission with multiple flights to send everything else up there to kind of like assemble something into space, that's a very difficult thing. We had a hard time doing that with the space shuttle to supply and build the International Space Station, right? So to think we're going to do that just for a Mars mission, it just makes the mission way more difficult. And again, if you can make this stuff on the planet or the surface that you're going to, whether it's the moon, whether it's Mars, you can do some pretty amazing stuff. You can change the whole design of the mission. And so let's see here. So like we said, it's an 18-kilogram unit housed within the Perseverance rover, about the size of a toaster. Jeffrey Hoffman says he's a professor of aerospace engineering at MIT. His job is to electrochemically break down carbon dioxide collected from the Martian atmosphere into oxygen and carbon monoxide. It also tests the purity of the oxygen that's coming out. So between February 2021, when it arrived on Mars aboard the Perseverance rover, and the end of the year, MOXIE has had several successful test runs. According to a review of the systems by Hoffman and colleagues, published in Science Advances, it has demonstrated its ability to produce oxygen during both night and day when temperatures can vary by over 100 degrees C. So, for us right now, we don't have to worry about 100 degree C swings here on Earth. But obviously, if we're talking about climate change and the planet warming over time and having more extreme weather, that's really good that this device isn't like a super sensitive thing and it only works in a narrow window. It's good that there's such a durable device that can produce oxygen this way. Now, whether we can get to the point where not just the oxygen but the carbon monoxide and really converting what we need to on Earth to reduce this climate change effect, that's still to be decided. But still, it's a huge step forward into making missions on Mars, human exploration on Mars, easier, right? We either need to terraform the planet or we need to be able to make enough stuff while we're there from the resources that are available to make a mission like Mars possible, because, again, it's basically like a 2-year trip that you're signing up for when you go to Mars before the orbits get to the point where you can do a Hohmann transfer and get back to Earth in a reasonable amount of time. So, MOXIE is doing some crazy stuff on Mars, really some sci-fi futuristic stuff that's really not being talked about a lot. So I wanted to bring that up. It's a lot of exciting stuff and some great examples of research that can be done to solve the really challenging problems of space travel that can then be applied here on planet Earth. I don't know what it is about humans that we don't want to solve problems like these without a real challenge or without the proper incentive, the right people making the money off of whatever it is that you're doing. But it's something about the incentive of the final frontier and helping human space travel happen. There's something about that incentive and what it brings to the people and the solutions that I really love. You know, our last episode was about space project progress incentives and how SpaceX and NASA are two totally different companies and places to work in the space industry, and they offer you different things, and they go about incentivizing the people that work there differently, and you can really see the difference even in that incentive of what it's like to work for either place and what you can achieve when you do that and the limitations that come along with that. So if we're talking about science that can really help us on Earth, like why are we spending that money? What is it going to do? I love both these examples. And one of the cool things about the 3D printing thing on Mars, which I think is a great topic to discuss for like sending humans into space and surviving. You know, the Apollo 13 example is one of the great examples and one of the most relatable things to what I'm talking about. When the astronauts couldn't convert the carbon dioxide and they were going to basically choke themselves out, deprive themselves, use up all the oxygen that was there because of the damage that they received on their spacecraft, the engineers had to dump out a box of everything else that was with them, right? The classic space problem. You can only have what you bring with you. And Mars is the extreme example of that. And so this 3D printing on another planet, especially with something like titanium, something really strong, and something that can make complex shapes. Let's say you have this 3D printer on Mars. That moment where they have that problem on Mars, instead of going, here's the box, figure out a workaround with what we have, the 3D printing enables the problem solutions, the problem solving on Mars to a whole nother level. Just like this MOXIE making fuel, because that changes the whole mission, right? Before, going back was not an option because you didn't bring the fuel with you. But if you can make the fuel while you're there, and if you can make another object, a converter, redesign the thing that it was originally made for to solve the solution that's in front of you, that opens up a whole other way of solving and making sure that you survive, right? It's a literal survival. And so having that 3D printer could be indispensable to a problem that without it is and could very well be the end of that mission and those humans' lives. But being able to have a wide variety of materials and design skills and other ways to solve the problem, it's amazing. There's nothing better than that. That is the coolest engineering mission. Those days will come and those things will be needed. So I love talking about the new stuff that's happening, that's developing, that's going to help humans live on other planets and do other things. Really cool articles. Go check those out. Those will be in this week's descriptions. You can check those out. Again, that's MOXIE on Perseverance Rover, and then the 3D printing on Mars with Martian regolith. We'll have both of those there. But finally, there is the DART mission, which is about to show us whether or not we're better than the dinosaurs. All right? The dinosaurs didn't have a space program. They weren't able to deflect the asteroid, and they got pummeled. And then we took over. All right? So we don't want that happening to us. So the double asteroid redirect test or DART, is an impactor spacecraft. I'm going to actually open this up here because one of the awesome tools that NASA has that's available to everybody is NASA's EYES. And NASA's EYES is like a 3D visual interpretation simulator of the different missions that they have. We followed that on the Perseverance mission, where we literally were watching it live. We even watched the beginning where it kind of like showed you what the landing on Mars was simulated, what they were expecting it to be. So you could actually see it with these high quality graphics. I mean, it's crazy. You could even travel the whole universe, go to different times and show through. But this one has the DART mission lined up. So we're going to pull that up. It's literally live. I'm recording this about 6. This is right now. It's 6:32 p.m. on September 17th, and so that's exactly the time that is on NASA's EYES here. So I'm just going to record my screen, and then we're going to go into NASA's EYES. So the DART mission. This is NASA's EYES. As you can see here, we can scroll out. We can rotate. And so it tells you more about the mission. So the launch was November 24th, 2021 on board a Falcon 9. It's an impactor. This is the binary asteroid Didymos and Dimorphos. And the DART mission will test whether a spacecraft impact could successfully deflect an asteroid on a collision course with Earth. So this is the actual Planetary Defense Coordination Office. So they are tasked with this kind of thing, and it was really interesting. Like a few years back, online, they have these like disaster scenarios of like what would happen if an asteroid impacted, and like what the damage would be, it was a crazy. A crazy thing to talk about without another option, right? If you don't have a solution for stopping the asteroid, everyone kind of looks around and goes, are we kidding? Like, what are we doing? We saw Bruce Willis do it with Ben Affleck. You know, like, come on. This is literally Deep Impact, right? This is literally things of sci-fi, and we don't have a plan. And so the DART mission is legitimately it's one of the longest game of billiards that we've ever seen, but literally that's what they're going to do. They're going to impact the spacecraft and see if the orbit of this dual asteroid system changes, and whether this kinetic impactor actually shows that we could deflect an asteroid. You know, if we see the asteroid soon enough and we hit it, we just don't need to hit it hard. We could just nudge it. We don't have to put a nuke inside of that thing and blow it up like they did in Armageddon. We just need to move it slightly at the right time, and it'll completely miss us. So I'm going to go to the DART mission website. And so the DART impact is planned for September 26th at 7:14 p.m. Eastern Time, and it's going to impact the moonlet Dimorphos, and that's going to try and put it in a new orbit a little tighter around Didymos. And one of the good things is that this was not ever actually something that we had to worry about impacting Earth. So it's a test, low stakes if it doesn't work. And so currently the orbital period of Dimorphos and Didymos is 11 hours and 55 minutes. And the separation between the two of the center of the asteroids is 1.18 kilometers or 0.73 miles. And the DART spacecraft will impact Dimorphos nearly head-on, shortening the time it takes the small asteroid moonlet to orbit Didymos by several minutes. So, great kinetic experiment. You know, it's like those two trains or two cars, that physics problem in high school, coming together to hit each other. What's going to happen in the resulting force, right? So I'm really excited to see where this goes. It's a cool mission. I think this type of stuff makes this is where the money in space should be going to. Let's figure out this stuff, right? We are on a giant spacecraft called Earth, flying around the solar system that's in this whole galaxy, the Milky Way galaxy, that we still really know extremely little about. And we know from looking back in the history that a whole reign of other things, giant lizards, ruled this Earth, and they went down because an asteroid impacted. And we know there's a good chance that could happen again. So why not try and figure it out? I mean, right? I mean, yeah, we're going to the moon, but also it would be good to defend against this, okay? It would be really good to have a backup plan. So, DART mission, I'm super excited for that. And I don't know how big they would have to make another spacecraft if it was a really giant asteroid. But again, this is about like strategic implementation of a force, right? Like the 1-inch punch of Bruce Lee, right? Or like if you use the right application of force in the right place at the right time, you can change the entire course of humanity. So one of the coolest missions that we've had in space in a while, all around humanity surviving our place here in the universe, whether it's on Mars to help make moon travel, Mars travel, and life on Earth better, but also things like DART that could protect us from getting wiped off the planet completely. So, and even an option with MOXIE to help cure the woes of climate change on our planet that we don't really have a good way of turning it around now. This is doing it on a totally different planet. So I don't know how big MOXIE would have to be, probably bigger than a microwave or a toaster. But if we can get a few of those here on Earth, we could do some stuff. We can really change things. That's one of the great things about science. A lot of these missions are talking about, which is all these things that we thought were not possible. And a lot of the science and research is going towards, we did make it possible. Now, how useful is it going to be? What can we really do once we've proven that this is possible? So, an episode, about 42 minutes here. So thank you for joining us. We really appreciate you supporting the podcast. Thanks for listening. If you're here this long, you guys are awesome. Thank you so much. As always, spread love and spread science. We hope you have a great week. And of course, all the other things help support the podcast. Liking and following the podcast is the easiest way. Sharing it with friends, it's free, and it does a ton. It gets more people here, gets more of us talking. And of course, if there's anything you'd like us to talk about here on the podcast, we're always open to suggestions. So hit us up, whether it's Today in Space Pod on Instagram and Twitter, Today in Space on TikTok, Today in Space Podcast on Facebook, our Facebook page there. And of course, our email, todayinSpacePodcast@gmail.com. Our 3D printing lab, AG3D Printing, and all of the ideas that we can bring into reality because of our 3D printers, our 8 3D printers in our lab here at Today in Space Studios. And we wish you a great week. Don't forget our sponsor, Manscaped, 20% off anything in the store, whether it's the complete performance package, whether you want the Lawnmower 4.0, the Weed Whacker, whatever it is for your male grooming needs that you need from Manscaped, you can check it out at manscaped.com, 20% off and free worldwide shipping when you use the code SPACE. Look, manscaping, I do it because it makes me feel good. Whatever your reason is, whether it's taking care of yourself, whether it's trying to impress somebody else, whatever it might be, Manscaped has the tools for your family jewels and for your wellness in general, right? They help make it simple, and they've got all the tools that you need, high-quality tools. Again, we found out on our trip from Florida that the Lawnmower 4.0 charges wirelessly, which is great. I was able to find a charger that did work, so I wasn't shit out of luck on that one. But manscaping, doing that on the road, making sure it's a bit of a confidence for me. I feel better, makes me feel good about myself. I'm also a Greek man, so look, there's a lot of hair to deal with. But the tools are simple, and the cleanup's great with the newspaper that they have. Just clean it all up, and again, I've got thick Greek hair, so it gets everywhere. I'm not trying to gross you out. It's just the reality, and the manscaping tools can keep up with that. So you know they're high quality, you know they're there for performance, and the performance package is there for a huge bundle that you can get 20% off with the code word SPACE and free worldwide shipping. So check that out if you want to help support the podcast. And as always, spread love and spread science. Live long and prosper. Have a great week, and we'll see you for another episode of Today in Space before the end of September. Have a good one. Enjoy those leaves changing if you got a fall in your area. It's a beautiful, beautiful time of year. Pumpkins, pumpkin spice, apples, the harvest. I'm very excited here. I'm glad I'm over COVID. Good to be back here on the podcast. I hope you have a good one. See you next time.